Hello and welcome back. It is me, Johanna. I still don't have any credentials. I am just using the official IB book. Today we are doing 1.3 and 1.4. I'm sorry for the huge break I took. I just burnt myself out a little bit. Today I decided I'm going to do it in a different way. The actual teaching part will be done by showing you my notebook, which has written words in it. Meanwhile, the examples I will be using, which I will be taking out of the book from now on. I thought this would be more reasonable since when I make up the things myself, which is fine, sometimes I'll make them up myself, it doesn't always seem relevant to what you might be asked in a test. So I will sort of be relying on the book's questions and I'll be explaining how to get the answer you're supposed to get. Yeah, so that's pretty much it. I'm gonna call this like mixed media since I'm using pictures and also the iPad recording. But really, in reality, it's just me being lazy. So, yeah. Chapter 1.3 is called Arithmetic and Geometric Series. So, as you know from the previous video, an arithmetic series would be the sum of all the terms of an arithmetic sequence. Now, when talking about these series, you use a certain formula to find the answers, and here are the formulas you can see at the top of this page. It is Sn, which stands for the sum of a certain amount of terms, equals the number of terms divided by 2, times the first term and the last term of the series. Now there is one more formula you could use, which is the other one that is after the or. These both are used for the exact same purpose. They're just depending on what numbers you have, it would be easier to use either one of them. Now, even though you don't need to know where these formulas come from, it might still be good to know to really be able to memorize it. So a quick little history lesson right now. So this German mathematician called Carl Gauss, I am not saying that correctly, but yeah, was the first to make this formula. And the reason why it happened is because he was trying to add up all of the natural numbers from 1 to 100. And basically what he did is he paired them up so that he took the last number and the first number. So he took 1 and 100, and then 2 and 99, 3 and 98, 4 and 97. And he realized that when you did this, you would always get the same number. Like 1 and 100 equals 101, 2 and 99 equal 101. So basically what he realized you had to do is you divide the amount of numbers you have, which is 100, so you divide it by 2. So you would have 50 pairs, and each of these pairs equal 101. So then it would be 50 times 101, which is 5,050. So basically, you can see how this formula got created. That's why we have n divided by 2, so it's the numbers of terms divided by 2. So that's basically where that comes from. Now for a geometric series, it is a little bit of a different formula. So a geometric series is essentially all of the terms of a geometric sequence added together, or the sum of that. So essentially with this, you would have your first term would be u1, and then it would be plus u1 times r, and then u1 times r squared, and then u1 times r cubed, so on and so forth. So then these formulas were derived, which are Sn equal the first term times the common ratio to the power of n minus 1 divided by r minus 1. So there are two versions of this formula, which is basically just whatever will give you the easiest numbers. So if r is bigger than 1, then you use the one where it's r minus 1. And if r is smaller than 1, then you use the one where it's 1 minus r, because that will just give you easier numbers to work with. Now, the next thing we need to talk about is converging infinite geometric series. This is essentially when a geometric series goes to infinity. There are an infinite amount of terms. However, it has become clear to me that in my previous video, I did not actually explain what converging and diverging actually means. So converging means that the number, like the more terms you get, are going towards 0. So every term is getting smaller and smaller, and it like eventually is going closer and closer to 0. Meanwhile, diverging means that it's going away from 0. The number is just getting bigger and bigger and bigger. So for this converging infinite geometric series, the formula is the sum of infinity equals the first term divided by 1 minus the common ratio. Now, in this case, the common ratio has to be smaller than 1. Otherwise, it would not be a converging series. Now we're going to take a look at an actual question. So this is from exercise 1J in the IB Maths book. We will be doing 1A and 1G together. So we have to decide whether the infinite geometric series below are converging, and if they are, we have to find the sum. So for 1A, the numbers are 0.25 plus 0.375 plus 0.5625. Now, already by looking at this, I know that it is diverging because it's increasing. It's not going towards 0. However, if you want to know for certain that this is diverging, which means that it's going away from 0, you would take the second term, which is 0.375, and divide it by the first term to find the common ratio. And if the common ratio is bigger than 1, then it is diverging, which is the case for this specific question. Now for G, we use the same process by taking the second term and dividing it by the first term, and we will find out that it is converging. For instance, the first term is 1 divided by square root of 2, and the second term is 1 divided by 2 times the square root of 2. So if you do 1 divided by 2 times square root of 2 divided by 1 divided by square root of 2, then you'll know that the common ratio is 0.5. Now to find the sum of this series, you would then take the first term, which is 1 divided by square root of 2, and then divide it by 1 minus r, and r in this case is 0.5, which would equal 1.41, which means that this series is infinitely getting closer and closer to this number, 1.41. The next example I will be showing you is from exercise 1K and exercise 9. So this exercise states that the first 3 terms of an infinite geometric series are m minus 1, 6, and then m plus 8. And then we have to write down 2 expressions for r, find 2 possible values for m, and hence find 2 possible values for r. Only one of these r values forms a geometric sequence where an infinite sum can be found. Justify your choice for r. And then lastly, calculate the sum to infinity. So this is quite a lot to do. So for A, which is write down 2 expressions for r, essentially what I did is how you find the common ratio. So there are 2 ways to find a common ratio if you have 3 of the terms. So you would do the second term divided by the first term, and the third term divided by the second term. And there you go. Those are 2 expressions for r. Obviously, you will not know exactly what it is at this stage. You would have to be doing some more math to figure out what r actually is. But these are just expressions for r, you know. So if we move on to part B of question 9, which is to find 2 possible values for m and also find 2 possible values from r using the values from n. So What do we know so far? We know that both of those expressions we just wrote are supposed to equal each other. So if we make them equal each other, we can find what m is. So that is exactly what I did. Since we are looking for two values of m, I thought the easiest way to do this is to turn this into the quadratic formula. So the quadratic formula is x equals negative b plus minus in square root of b squared minus 4 times a times c, and all of that divided by 2 times a. Now, I assume that you would know this previously, so I am hoping that that is the case. However, if that is not the case, you should definitely go and learn the quadratic formula because it is very helpful in this situation. So the thing with the squared is what a was, the thing with the m but not squared is what b is, and the coefficient is c when I was explaining it before. Obviously, we're not using x, we're using m in this situation. And essentially, I did this formula and I found that it was either 4 or negative 11. Now that I have the values of m, I can then move on to finding two possible values for r. Now, how I do this is I take my expressions from r that I made in part A of this question and I plug in those numbers. So I plug in the 4 instead of the m, and then I plug in the negative 11 instead of the m. And look what I got. Two different answers. I got 2 and 0.5. Now, however, in part C, it says that only one of these can be used to find the geometric sequence where an infinite sum can be found. Remember, this infinite sum, this means that it's converging, which means that the number would have to be less than 1. So 0.5 is the one to use. Now that we know that, we can calculate the sum to infinity. So we calculate the sum to infinity by taking the first term, which is m minus 1, but since we chose the common ratio 0.5, we would have to use the m that we used in that situation, which was negative 11. So we would use negative 11 divided by 1 minus 0.5. And that would be our answer, which would then equal negative 24. Now we are moving on to chapter 1.4, which is applications of arithmetic and geometric patterns. So these two applications that we will be talking about in this chapter are interest and population growth. So we will begin with interest. So interest is what you are charged for borrowing money. There are two different types of interest. There's simple interest and there's compound interest. So simple interest is paid on the initial amount borrowed, saved, or invested, which is called the principal, only, and not on the past interest. This means that every year the same amount of interest is added. This does reflect an arithmetic pattern. Meanwhile, compound interest reflects a geometric pattern. Now, compound interest is paid on the principal and the accumulated interest. So essentially, you're paying interest on interest. This means that every year, the number for interest will be different. Now, the formulas you have to remember for interest is there are three different ones. For simple interest, there is A equals P, and then times 1 plus n times r. So let me explain what all of these aspects mean. So A represents the accumulated amount, P represents the principal, R is the annual rate, and N is the amount of years. Now for compound interest, it is A equals P times 1 minus R to the power of N. So these letters still mean the same thing. So P stands for principal, R is for annual rate, and A is for accumulated amount, and N is for time. Now, you also need to know the formula for compound interest over a non-year period. So if you get something where it says that it is not paid annually means paid once a year. If it says instead that it's paid monthly, you have to use this different formula, which is A equals P times 1 plus R divided by N to the power of N times T. Now, in this situation, A represents the final amount, P represents the principal, so that is, P represents the initial amount that you invested or borrowed or whatever. R is the annual rate. However, N is the number of compoundings in a year, which means the number of times you have to pay in a year. So if it's paid monthly, N would be 12 because there are 12 months in a year. That is the amount of time a year you are paying. And then T is the total number of years. So now N doesn't mean years, N means, monthly or whatever the aspect may be. It might be like a weekly. You definitely don't say weekly, but like it could be any number. So that is very important to remember. So the last thing we have to go through before we get into doing some exercises is population growth. So population growth is an increase of numbers in individuals over a certain period of time. So this could be any country, anywhere, and it has to be based on the number of births and deaths over a certain time given for a specific population. So something to remember is that if you were asked to evaluate your question, like if you get a question about population growth and they ask you like, is this reasonable? Then you have to think, is this actually representing the amount of people, like everybody alive in the population and everybody who's died in the population? Because if it doesn't, then you can evaluate and say that it's not very good. Now, other than that, I don't really have much to say about population growth. So the first exercise we will be doing together is from exercise 1L, and it's number 8, which is that this person has 4,000 Egyptian pounds to invest. He wants to split his money equally between a savings account with simple interest at a rate of 1.2% and paid annually, and then a 2-year guaranteed investment certificate with an interest rate of 3.5% compounded monthly. How long will he have to leave the money in the savings account so that it earns the same amount as the GIC account? The goal of this question is to find out a way to make these two different situations equal to each other. So we have to set up a formula. So he has 4,000 Egyptian pounds and he wants to split them equally. So then the principal on both sides needs to be 2,000. Now, there are two different things going on right here. The first one is simple interest. The second one is compound interest. The second one is not just compound interest, it's compound interest over a non-yearly period. So you have to use that formula, and then you have to use the simple interest formula. So then you just plug in those numbers. So for the simple interest, it would be 20,000 times 1 plus n times 1.2, because obviously we don't know how long it needs to be in there for it to become equal to the other account. So n is just n. We are looking for n, And then on the other side, it would be 20,000 times 1 plus 3.5 divided by 12, because you're paying it 12 times a year, to the power of 24, because it says that it is, in the question, it says that it is a 2-year guaranteed investment, which means that it would be 2 years. So you would take 12 times 2, which is 24, and that's why it's to the power of 24. And then you just work it out. You just follow this until you isolate n and you find the other side. N turns out to be roughly 6 years, a little more than 6 years. So now the next exercise and last exercise we will be doing is question 3 from exercise 1M. Question 3 is, half-life is the time required for a substance to decay to half of its original amount. Part A of this question is, a radioactive isotope has half-life of 1.23 years. Explain what this means. B is, write a general formula to calculate the amount remaining of the substance. C is, use your GDC to sketch a graph of the situation. D is, if you start with 52-gram sample of the isotope, how much will remain in 7.2 years? Now in this video, we will only be doing B and D because C, I couldn't really be bothered to bring my calculator forward. Also, it ran out of battery. Oops. And A, even though we will grasp upon it, this basically means that, the answer to A is literally just that it takes 1.23 years for the isotope to decay to half of its original amount. That's pretty much the answer to A, so I didn't feel the need to write it down. Now for part B, even though I did write A here, but I mean B, we have to write a general formula to calculate the amount remaining of the substance. So basically, we know that this is a geometric. Each term becomes 0.5 times the previous term. So that's what I figured out at first, which I figured this out by saying that it's half of its original amount. So then you basically just do the formula for a geometric sequence, which is the first term times 0.5 to the power of n minus 1. But then again, now we know that the span is 1.23 years, so it has to be n minus 1 divided by those amount of years, because otherwise we wouldn't know how much time it actually took. And here I also wrote C instead of D, fun, but basically here you just plug in the 52 grams into the formula you just created. Now these numbers, for the squared part, that number became so long that I didn't even bother writing it, so I just wrote the answer instead. But when you do it with a calculator, you should get this answer, which is that you will remain with 1.58 grams after 7.2 years. Now that was it for this video. Thank you for watching. Please subscribe, like, and comment. And you can follow me at Johanna Frennert if you please. I hope you learned something. Goodbye.